Hello everyone, welcome to the coding tuition. In the previous video we have seen mathematical operations on Numpy arrays. In this video we will see three important concepts: aliasing the arrays, viewing in arrays and copying in arrays. So let's start with the video. To understand aliasing in arrays, we have created an array A, and in that there are 5 elements: 1, 2, 3, 4 and 5. Right? If you know a little bit about Python, in Python everything is object, right? So when we created an array A with elements 1, 2, 3, 4 and 5, how internally it works is, first array is created in the memory with 5 elements and we are referring that array with name A. Okay, now let's see what happens if we write B is equal to A. When I was learning Python, what I thought is, when we write B equal to A, it just means we created a new copy of array A. So basically now we have two arrays A and B, and elements of both the array are same, that is 1, 2, 3, 4 and 5. But this is not true. Now let's see why. Here B equal to A, this simple assignment does not create a new copy of array A. What we are doing is, we are just giving another name to the already existing array with 5 elements. So initially, before executing this statement B equal to A, how it works is, first there is an array in the memory, and that array we are referring through a variable or a name A. Okay, now we wrote B equal to A means we are accessing the same array with the name B as well. So now the array which have 5 elements 1, 2, 3, 4 and 5 have two names or have two references, B and A. So here B does not take any memory. Okay, it's just a new name to the already existing object or array. So this concept is called as aliasing. Aliasing means it's just giving a new name or new reference variable to already existing object. Okay, now I told you that it is referring to this already existing array. How to prove it, right? So in Python there is a function id. So what this id function tells is, it gives the memory location of the object. So here if we print id of A, so what happens? A is referring to the array. So that means when we print id of A, it will give memory location of this array. Now let's see what is the memory location of this array. So here we got the memory location as 283 something something 320. Okay, now let's print the same id for B. As you can see, both the IDs of A and B are same. That means both A and B are pointing to the same memory location, that is they are pointing to the same array. This memory location is the memory location of the array. If B would have been pointing to another new array, so this ID would be different. Okay, so I hope you have understood the logic of aliasing the arrays. Just a quick revision: in aliasing we just give another new reference to an already existing array. It does not create any new object in the memory. Okay, let us understand viewing in arrays. In aliasing, as we understood, there is only one object and we just gave a new name. Okay, but what if we want to create an actual copy of the already existing array? So let's first create an array P. Let's have the values 2, 4, 6 and 8. Okay, now what we need is, we need to create a new copy of the array, not like aliasing where we just gave a new name. We actually need a new space or a new copy of the already existing array. So let's create a new array Q, and this array will be a copy of P. So there is a function called view function. What we will write is P dot view. So what it will do is, it will copy array P to Q. Now let's print both the arrays. Print P and print Q. As you can see, there are two arrays. Both the arrays have same element, but as we discussed earlier, when we printed id of A and B in aliasing, the id was same, but here the id will be different. So let's do this. Let's print id of P and id of q. So here as you can see, both the IDs are different. Why? Because when we copied array P to Q, a new array is created with same element, which means when a new array is created, a new space is allocated. So both P and Q are different arrays, but the elements of both the arrays are same. Okay, what we did is we created an array P and we just copied the array P into array Q using the view method, and we have confirmed that both the array P and Q are at different memory location using id function. Okay, let's see what is the problem in view. Let's access the first element of P, that is P of 0. Let's change it to 10. Okay, now let's print array P. So here initially P was 2468, now we have changed the first element, that is P of 0 to 10. Now the array is 10468. Now let's print array Q as well. See what happened. We changed the value of the first element of array P, but it also changed the value of the first element of array Q. So what is the problem in view is, in view, even if we have created two different arrays, both the elements of the arrays are mirror image to each other. So whenever we change either of the array, it will reflect to the other array as well. Here both the arrays P and Q are not independent, they are dependent to each other. So this is why view is not a good option to copy the arrays, because both the arrays are dependent to each other. View is also called as shallow copying. So now what is the solution if we want to make both the arrays P and Q independent? For that, copying in arrays come into the picture, where we will use the copy method. Okay, and this copying is known as deep copying. So let's see an example. Now let's create a variable x equal to array 1357. Okay, let's print. This is the array. What we will do is, now we will create another array y. It will be also a copy of x, but here we will use the copy method. Why? Because in view method both the arrays P and Q were not independent. To make arrays independent of each other, we are using the copy method. Okay, now we will print y. Elements of x and y are same. Now let's confirm this again with id function. We will print id of x, then we will print id of y as well. So here as you can see, both the IDs are different from each other, means a new copy of x is created in the memory and it is referenced by variable y. Okay, let's change the first element of x to 13 and then let's print x. Here what happened? Here initially x was 1357, now x is 13357. Now let's print y. Y initially was 1357, and after changing the value, the first element of x, then also y, the value of y is not changed. So we can say that both the arrays x and y are independent. Why? Because we have used the copy method, not the view method. Okay. So this was it regarding aliasing, viewing and copying in arrays. So let's do a quick revision. Aliasing is basically giving a new name or a new reference variable to the already existing object. Okay, this is not, aliasing is not copying. To copy there are two methods, viewing and copying. The problem in view method is it creates two different arrays, but both the arrays are mirror images of each other. So changes in one array will also change the value of other array. To overcome this problem, we have used copy method, which is also known as deep copy. So here we have created two arrays x and y. Both are independent of each other. When we have changed the first element of x, then also it doesn't change the value of y. So here we can conclude that arrays are independent of each other. Okay friends, I hope you all have understood this video, and if you found this video helpful, then do like the video and subscribe to the channel, and if you have any suggestions, please comment down below. Thank you.